All right, continuing 8.4 Roman number 6. So once again we'll try to prove that left hand side is equal to the right hand side. So have a look at the left hand side. It is under root, and then we have 1 plus sine a, 1 minus sine a. So first thing, we'll try to remove the root, okay, because when you look at the right hand side there is no root or anything, right? So how do we remove the root? We'll do it by rationalizing the denominator, okay? So you can see minus is here, so there will be 1 plus sine a, 1 plus sine a, right? Okay, once we are done with that, when you look at the numerator here, can you see it is out of form a plus b, a plus b, a plus b, a plus b, right? So which means that I can simply write it a plus b the whole square here, okay? If you look at the denominator, a plus b, a minus b, a plus b, a minus b, how can we write a square minus b square? So a square minus b square, okay? And now we already know from the formula that I mean, before that, 1 square is simply 1, right? Which means what? What are we having here? We're having a 1 minus sine square a, which gives us what? Cos square a. Okay, so once we're done with that, we can simply divide the square and the root here, and we'll be left with 1 plus sine a by cos a. So next, the final step, just separating the denominator, LCM or the denominator, okay? 1 by cos a, and then what? Sine a by cos a. Right, then 1 by cos a, what is it? 1 by cos a, it equals to sec of a, right? And then sine by cos a, it gives us then a, so which is equal to our right hand side. All right, Roman number 7. So once again, left hand side equals right hand side. That is what we'll be proving, okay? So let's start from the left hand side. So I've written the left hand side here. So remember, our answer should be tan theta, okay? So when you look at the numerator, sine theta, then 2 sine cube theta, right? So we can see that sine theta is common to both. That is why we're taking the common out, okay? So for me, if I've taken out the sine theta, only one is left, right? And then next will be minus 2. It was supposed to be cube, but we have taken one sine out, right? So which means now it will be sine square theta will be left. We'll do the same thing with the denominator. You can see the cos theta is common, right? So I've taken out 1 cos theta, so 2 will be there, and then it was cube, but now it will be square, and this cos theta has been taken out, so now it will simply be minus 1, right? So once we are done with that, next step will be, we'll try to expand this sine square theta. We already know sine square theta is what? 1 minus cos square theta, right? So 1, then minus 2, we can't do anything, so write it, but this sine square theta can be written as 1 minus cos square theta. All right, so next step we will start multiplying, okay? So you can see this is minus 2 here, right? Minus 2 into 1 minus 2, then the next will be minus into minus, we get plus here, right? Then 2 cos square theta, right? Multiplication and opening the brackets. Now when you look here, can you see that this is 1 minus 2, which will give us minus 1, right? So you can see our minus 1 is here. All right, so now what we're trying to do is we're trying to divide it, okay? So can you see minus 1, then 2 cos square theta, 2 cos square theta, they are same, right? Which means that we can divide this and this. We'll be left with what? Sine theta by cos theta, which is equal to tan theta, or we get the right hand side, right? The answer. All right, question number 7. So pretty long. This is what we're supposed to prove, okay? This is our answer here. All right, so let's start. So pretty simple. The first part is just expand the formula, okay? So this is our a, this is our b. A plus b the whole square. Same thing again, a plus b the whole square. So what is the formula? A square plus b square plus twice a b. A square plus b square plus twice a b. Okay, just expanding it in the the formula, right? So once we've expanded, I'm going to keep this sine square a and this cos square a together. Why? Because we already know that sine square a plus cos square a gives us 1. All right, now have a look here. So sine a, just leave it as it is, but this cosec a can also be written as 1 by sine a, right? Sine a equals 1 by cosec a, and then once again we'll keep this what? Where is cosec? This cosec square a and this sec square a together here like this. All right, and the next part here, once again, cos a, just leave it as it is, but this sec a, we'll write it down to be 1 by cos of a. All right, so once we're done with it, we can divide this sine a, and this cos a, and this cos a. So once again, sine square a plus cos square a gives us 1, right? Then we have a 2, so I've written it down here. And when you look at cosec square a can be expanded now from 1 plus tan square a, because see, when you look at the right hand side is in terms of tan square and cot square a, right? We don't need cosec or sec, okay? We need it to be in terms of tan and cot. That is the reason why we're expanding this cosec square a and sec square a, okay? So cosec square a gives us this, and then sec square a gives us this. Once again here only 2 is left, so I've written it down here, 2. Right, so once we're done with that, we'll open a bracket. Then if I open a bracket, it will be what, 1 plus tan square a, then 1 plus cos square a. Now start counting the numbers, 2, 3, 4, 5, 6, 7, right? And then tan square a plus cos square a, which is our right hand side. All right, question number 9. Here we have to do both the left hand side and the right hand side one after the other. Okay, you will know the reason why. So cosec a, I'm going to simply write it to be equal to 1 by sin a. Same thing with sec a, I'm going to write it down to be 1 by cos of a. Okay, so you can already see in this step here. Once we're done with it, remember what is below here, 1, same thing here, 1, right? So if I try to find the LCM of sin a and 1, you'll obviously be sin a itself. So what is my first numerator? 1. Sin a, how many times the sin a? 1 times, right? Next is minus sin a, so I've written here 1 is below, 1 is in the denominator, so 1, how many times the sin a? Sin of a. So finding the LCM, right? We'll do the same thing with the next. So if you look again here, 1 is there, so obviously my LCM will be cos of a. Right on the first numerator, 1. Cos a, how many times the cos a? Cos 1 time, right? Then again 1 is here, denominator is 1, right on the numerator, minus cos a. So I've written then 1, how many times the cos a? Cos of a. So once we're done with that, let's start multiplying. 1 1s are 1. Sin a into sin a, sin square a. Same thing for the other side too, right? If we do again 1 1s are 1, then cos a into cos a, we're going to get cos square a. Of course, the sign is minus here, right? So we already know 1 minus sin square a gives us what? 1 minus sin square a. The formula is cos square a. Right, so I've written here, and same thing again. 1 minus cos square a gives us sin square a. So I've written it down here, right? Once we are done with that, we'll open the bracket. So you can see, because remember, multiplication sign is here, right? So now let's start division. This square and this cos will get cancelled, and then this square and this sign will get cancelled. We're having cos a sin a, which is not how our right hand side is, right? So here, like I said in this question, we have to do both the left hand side and the right hand side. So let's start with the right hand side again. So here once again, tan a can be written as what? Tan a can simply be written as sin a by cos of a. Same thing for our cot, okay? Cot a can also be written as cos a by sin a, and we're doing that because when you look at the left hand side, it is in terms of sin and cos. All right, so I've written it down, tan a sin a by cos a, and cot a cos a by sin a, right? So once again, we'll try to find the LCM, but the LCM will be just these two again, right? So sin a cos a. So write down the numerator. First numerator is what? Sin a. So I've written cos a already there. What is not there? Sin a. So you write it down, the sin a. Okay, let's go to the next. The numerator is cos a, so I have written, and now look at the denominator. Sin a already there. What is not there? Cos a. So we'll write down this cos a. All right, so the next step, we will change this this division into multiplication, right? So nothing happens to whatever is at the top. So you can see 1 is here, but these two will change their positions, right? So this will go up, and the whole thing, this will come down to the denominator. All right, so sin a into sin a, we're going to get sin square a, then cos a into cos a, cos square a. But we already know that sin square a plus cos square a equals 1, right? So which means what are we left with? We're left with sin a cos a. So which, if you look, left hand side is also cos a sin a, and now we already got even the right hand side to be equal to sin a cos a. So they are both equal to each other.